Today we're going to talk about chemical names and formulas. This is called nomenclature, which is just a fancy way of saying what are the rules for naming a chemical. So if you're given a formula, can you come up with a chemical name that any scientist across the world will understand? After today and the next several videos, the answer will be yes. So what we're going to be trying to do in the next few videos is if I give you a formula, will you be able to give me the chemical name, the standardized chemical name? And if I were to give you a chemical name, can you give me the actual formula? That is our goal for the next for this unit. So before we get too far into it, let's talk about what the difference is between a name, a chemical name, and a formula. Well, the chemical name is just the words. Dinitrogen pentoxide. It's kind of like the official name of a molecule or of a compound. Dinitrogen pentoxide, hydrochloric acid, trinitrogen dichloride, thallium chromate, tin 4 oxide, lithium fluoride. Those are all names. The formulas are things like things with the symbol and the number of elements we have in your formula. So for instance, H3PO4 means that we have 3 hydrogens and 1 PO4, 1 phosphate. That's a polyatomic. This guy is called phosphoric acid, by the way. It is found in Coca-Cola. You've got carbon monoxide, CO, that's carbon monoxide. You have PBr5, phosphorus pentabromide. You have lead 2 nitrate. You have magnesium sulfide, MgS. These are your formulas. And if you notice, when I'm giving you the formulas and then giving you the names, they sound a little bit different depending on whether they're on the left side of this table or on the right side of the table. And that's because everything on the left is a molecular compound. What is a molecular compound? A molecular compound is a compound that is covalently bonded. Remember, I say the word molecule, that's synonymous with covalently bonded compound. The stuff on the right are your ionic compounds, and they've got a different naming scheme. So one of the first things you have to do when you're naming things in chemistry is you need to be able to identify what type of molecule, what type of compound it is. We're going to focus right now on whether it is an ionic compound, a covalent compound, or if it's an acid. Those are the 3 things we're going to focus on in this unit. Let's start by defining what a compound is. A compound is 2 or more elements, things straight off the periodic table, that are chemically bonded. And overall, the compound is electrically neutral. That means it might be made up of things that have charges, but overall, when you put those things together, it is electrically neutral. So if you have things that have charges within the compound, like an ionic compound, the charge of the cation must equal the charges of the anion. Okay, so for instance, H2O, this is a covalently bonded compound, a molecule. There is no charge whatsoever. NaCl, sodium chloride, this is an ionic compound. It is made up of a sodium ion, which is positively charged, got a +1 charge, and a chloride ion that is negatively charged, got a -1. But overall, the whole molecule is electrically neutral. You also have this tin 5 phosphate. Tin there's 3 tin molecules and each one has a charge of +5, and there's 3 of them. Then you have a phosphate, that is your polyatomic. There's 5 of those and each has a charge of -3. That means that your positive side is a +15. That's it's a charge of 5, 3 of them, 15. And your negative side is also 15 because phosphate has a charge of -3, but we have 5 of them. So it is a -15. So our positive side +15 and our negative side -15 cancel each other out, and overall the compound is electrically neutral. There are 2 main ways to name chemical compounds, like I said before. First of all, you must be able to identify whether something is ionic or whether something is covalent. So we're going to briefly review what it means to be ionic and what it means to be covalent. And then we're going to start off with talking about the naming scheme for covalent compounds. So we're going to talk about those two types of chemical compounds. We're going to give examples first of each, and then we'll talk about what an ionic compound is and then what a covalent compound is. So let's give some examples. Ionic compounds are things like table salt, rock salt, sodium chloride, NaCl, made up of a metal plus a nonmetal, a cation plus an anion. Calcium carbonate is made up of a cation, which is Ca2 plus, and an anion, which is this polyatomic CO3 2 minus, calcium carbonate. Potassium nitrate. Organic compounds are made up of a cation and an anion. Many times we say it's made up of a metal and a nonmetal. That's not fully true. It has to be a cation and an anion, because your anion can be a polyatomic. Your cation can also be a polyatomic as long as it's positively charged. When you look at your molecular compounds, in other words, the compounds that are covalently charged, they are things that are made up of only nonmetals, things like sugars, carbon, hydrogen, oxygen. 12 sugars, 12 carbons, 22 hydrogens, 11 oxygens. Those are covalently held together. Methane gas, which is what you use to cook with out of your stovetop. CH4, this is a covalent compound, but they look slightly different. So let's talk about an ionic compound first. An ionic compound is a compound that is formed from ions of opposite charges. In other words, you need a cation and an anion, like I just said. And because it's an ionic compound, your electrons are transferred from the cation, typically a metal, transfers its electrons. Why does it transfer? To get that oxide it wants, to an anion, typically a nonmetal or a polyatomic. Why does the anion accept those electrons? To get an oxide. Remember, that's what they want to do. So if you look at these examples, NaCl, Na is a metal, Cl is a nonmetal. Na is an Na plus, it's a cation, and Cl is an anion. Same thing here with tin and phosphate. Tin is a metal, it is a cation. Phosphate is a polyatomic with a negative charge. The smallest unit you can find for an ionic compound is called a formula unit. When you write down your ionic formulas, you must write it in the most reduced format possible. Now we're going to come back to ionic compounds and nomenclature in a little bit. We're going to talk about the nomenclature of a molecular or covalent compound. Okay, so let's talk about what a covalent compound is. A molecular or covalent compound is formed from non-metal atoms, things on the right side of the periodic table, formed from two or more non-metal atoms, or even one non-metal atom bound to itself, held together by covalent bonds, which means that the electrons are electrons are shared. There is no charge involved. Your electrons are shared. Things like water. C8H18 is oxygen. That's what your gasoline is made up of. Those electrons are shared. There's no charge in sight. And while with an ionic compound, we have to reduce the formula to the smallest unit possible, we do not do that for covalent compounds at all. And just to remind you, the smallest unit is called a molecule for a covalent compound. Smallest unit for an ionic compound is called a formula unit. The next video, we'll talk about how to name covalent compounds.